Hello and welcome to VJAG, everyone. We're really excited. Today is our March event. And we've kicked off the new year really, really well. My name's Sam Hepburn, for those of you who don't know me. And whether you're watching this live right now or you're catching up on YouTube later, we're really excited to have you here. We've got some amazing content lined up for you. If you're new here, welcome to VJAG. We're a virtual Java user group, which means that we are bringing the global Java audience together. So whether you don't have a local Java user group or you just want even more content, you're at the right place. We've also launched a new series called VJAG Connect, which means that we live stream local Java user groups. We live streamed Chicago JAG a few weeks ago, some amazing sessions there, and we've got the London Java community being live streamed on the 25th of March. So check out our meetup page for those details, which means that you get to see content even from local JAGs. If you're watching from a JAG and you want us to live stream your event, please reach out to us. We're on Slack or Twitter or X or Blue Sky or anywhere, and we'd love to live stream your event as well. Now I mentioned Slack. Slack's actually the best place to chat during the session as well as after the session. If you're watching this on demand, again, you'll be able to ask our speaker questions or speak to your fellow Java community members. So please join us on Slack. And I think I have a Slack image over here somewhere. There we go. So that's the URL to join us on our Slack community. But today, if you want to ask any questions to our amazing speakers, you can actually pop your questions in the chat. So I'd love to know where everyone is watching from today. So if you want to pop in where you're watching from, I'm personally based out in London at the moment, even though my accent is not from the UK, but wherever everyone else. We've got some people from Chicago, from South Africa, from Turkey, from Chile. So some awesome folks from all over the world. So please keep putting in the chat where you're watching from. But today's session, we're going to have an amazing host. His name is Elias. And other than being one of the nicest humans I know, he is also a principal software engineer and Java champion. So I'm going to bring him onto stage and let's have a little chat about our speaker. Hi, Elias.
Hello. Hello. How are you doing, Sam?
Very good. Welcome to VJAG.
Thank you. Yay. And a special day, actually. Yeah.
Amazing. Much more halfway
Yeah.
to DevOps UK. So yeah, if people don't know what DevOps UK is, they're our sponsor. They help us keep the lights on because unfortunately virtual events aren't free and we have to live stream and stuff. And they're also a UK Java conference in London on, I'm going to get all the dates wrong. I think it's the 9th to the 10th, the 8th to the 10th of May, the first weekend in May. And there's some awesome content and I hope to see you there. I also think our JAGs get a discount. So join the Slack community and find the discount code. The other event we've actually got coming up, if you really enjoy Dan's session today, I have just launched a AI conference. It's a virtual conference, so you'll be able to tune into that too. And it's called AI Native DevCon. And if you go to ainativedev.io/events, you can grab yourself a free ticket as well as sign up for our CFP if you've got any very cool sessions to submit. Other than your normal conference sessions, we've also got this really cool track called Tools in Action, which we will get our speakers to actually show what they're building with AI, not just a demo of a tool, but what are they using for, how are they building it, how are they putting it into their software development lifecycle, like some proper hands-on stuff. So also tune into that. But Elias, we're not here for me to talk about DevOps and AI Native Con and all those other events. We are here because we have an amazing speaker joining us. He is a Spring developer advocate. His name is Dan Vega, and he is a true expert in all things Spring. And he's going to be diving into building intelligent apps with Spring AI. So again, if you've got questions for Dan, pop them in the chat. We're also live streaming on LinkedIn today. So if you don't have a YouTube channel, unfortunately, you can't actually make comments, which is very annoying. So if you are watching us from YouTube and you want to write in the chat where you're phoning in from, but you can't, and you don't want to start a YouTube channel, don't worry. If you pop over to our LinkedIn page, you can pop comments there and they'll also come through to us. And then the lovely Elias will hand them over to Dan. And we've got actually a confirmation. DevOps UK is the 7th and 9th. Thank you so much, Ahan. But yeah, let's bring Dan to stage and get this party started.
What a wonderful introduction. Thank you so much.
No worries. Well, welcome. I'm actually going to hop backstage, but I'll be here, but I'll leave Elias and Dan to take over.
Cool. So, hi everyone. By the way, if you guys are not asking questions during the talk, I will ask a lot of questions because this topic is super, super, super nice. And by the way, it's basically combining two of the best topics which Java developers love, right? Spring and AI. So we love to talk about Spring. We love to use the tool, the framework, but also we are loving a lot AI. And we do have a lot of nowadays a lot of questions about how we can use it in our preferred framework. And I'm super excited to facilitate this with them because this will be an awesome talk. So you will be talking about specifically building intelligent applications with Spring AI, right?
Yeah, I think really what we're going to go into is I want to start with like a little bit of an overview because we throw this term AI around and it's like, what does that really mean, right? So we'll kind of cover some fundamentals just so we're all on the same page. We'll talk about Java. Where does Java fit into AI, right? Because I think a lot of times we hear AI, we kind of associate that with Python. Rightfully so. There's a lot of frameworks and tools for building large language models. But then we'll talk about like, hey, where does Java fit into this? And hey, where does this project Spring AI kind of fit into all of this as well? So I think a little bit of something for everyone.
Awesome. So just the last reminder, guys, ask a lot of questions. We'll be here like seeing the questions and you have the opportunities to have all answered. Cool. So then thank you again so much. So the floor is yours.
All right. Let me go ahead and throw this up. All right. So this is Spring into AI, building intelligent applications in Java with Spring AI. My name is Dan Vega. I'm a Spring developer advocate at Broadcom. If you want to find out more about me, you can visit danvega.dev. I'm a husband and father. We live outside of Cleveland, Ohio. I am a Java champion. I've been doing this for a long time. I hate putting this number up here. It makes me feel old, but it also makes me very proud of like all the things I've done in my career. And I've worn many hats in my career. This is probably my favorite hat, being a Spring developer advocate, because long before someone was paying me to do so, I was a Spring developer advocate. One of the things I kind of like to share with the community is that you don't need permission to advocate for the things that you're passionate about. It's done a lot of really great things for me in my career. So get out there, talk about the tools that you're using, the frameworks that you're using, give a lunch and learn at work, talk to a meetup, submit a CFP to a virtual Java user group like this one. And you never know where that's going to lead. I'm also a soon-to-be author. I've written many thousands of blog posts, but never a book. So this is my first book. I'm excited about this with my friend Nate Shuda. We are writing a book called The Fundamentals of Software Engineering, from Coder to Engineer. If you are on the O'Reilly platform, you can get early access to this now. I just want to mention two other quick resources. Spring Office Hours. This is a live stream we do every Monday from 1 to 2. If you want to get caught up with everything that's going on in the Spring ecosystem, this is a really good place to check that out. There's a replay. We also turn this into a podcast, so you can get this wherever you get your podcasts. And finally, I also am really kind of wrapped up in this world of AI. So I've been, the best way to kind of learn something is to teach it. So I've been writing about this a lot lately. So if you're interested in just kind of general AI stuff, I have a free newsletter on that. So as I mentioned at the beginning, what are we going to talk about? I want to jump into some just general terms because we hear a lot of these terms thrown around. What do they mean? What does it matter? Like, how does it relate to the things that we're doing when we're building, say, like generative AI applications? So we'll cover some terms there. Where does Java fit in? What is this Spring AI thing, and how do we use it? And finally, we'll do some live coding. Probably the second half of this, we'll get into some code and do some live coding together. So I think a really good place to start is with the term artificial intelligence. We hear this term thrown around a lot, but what is it, right? AI is really a technology that helps computers do things that typically require human intelligence. So for the longest time, being able to understand language, recognize pattern, make decisions, learn from those experiences. I like to think of AI as like tools in a toolbox. Some tools do one job really well, like image recognition. Some tools kind of work together to solve more complex problems. The tools keep getting better as we use them. One of the things I like to say is like, as exciting as all of this is probably the worst it will ever be, which is kind of scary. Just how good as some of these things are these days, right? I think another term to kind of start with is machine learning. Like many of the terms in the field of AI, machine learning isn't that helpful. It suggests we could just put a machine in a room with a bunch of books and then it's going to learn on its own. And that's not really the case. So when we talk about machine learning is a subset of artificial intelligence that focuses on developing algorithms and statistical models that enable computer systems to improve their performance on a specific task through experience. This is much different than how we're used to traditionally building applications, right? We give something, a system, explicit instructions on how to do something, and it follows it. From a machine learning standpoint, they learn from patterns of data, allowing them to make predictions or decisions without explicitly being programmed for each possibility. So what does that mean? What are some traditional use cases of machine learning? Well, facial recognition is a really big one, right? And some of this falls into kind of labeling these things. So if I have a bunch of images and I label Dan in, say, 10, 20 images, whatever the data set is, and I hand it a new picture and don't have any labels in it, it should be able to figure out that I am in that picture because it's seen enough data that was labeled Dan, and it knows how to kind of recognize me now. So we can do this with things like tumors on x-ray scans, abnormalities on ultrasounds, self-driving mode, fraud detection. So it knows kind of your spending habits. It knows what you're doing. If it is given a transaction, it will be able to kind of figure out, is this fraud or is this legal? When you go on YouTube and you see all the things, the recommended videos there, that is based on like an algorithm and your previous watch history and the things that you like to watch. So it'll kind of recommend those. And then things like spam filtering. So again, a lot of machine learning things, at least the examples that we're talking about now, are because we are labeling the data. I said, this is Dan, this is Dan, this is Dan. And then I hand it this picture. It should be able to kind of figure out who that is without being told so. So that's just a high level of what machine learning is. And really all this is made possible because of another technique called deep learning and neural networks. If you look at the human or the animal brain, that contains enormous amounts of nerve cells called neurons. And those nerve cells are connected to one another in vast networks of called neural networks. The human brain has something like 86 billion of them, which is kind of crazy to think about. So now if we're in this artificial intelligent world, we have machine learning. Deep learning is a subset of machine learning. And this is what uses artificial neural networks with multiple layers, hence the word deep. And these neural networks are inspired by the structure and the function of the human brain. Now, what makes these so powerful? Well, you can imagine this neural network of complex web, similar to like neurons in the brain. And each connection has a weight or that strengthens or weakens the signal that passes through it. So you can imagine like one layer might come through and detect edges on an image. Something else might recognize shapes. Deeper layers can like find eyes or a nose. And the final layer might kind of put it all together. So we have all these layers kind of attacking this problem at the same time. Now, what makes this possible is really, again, the idea, I think, of building a computer network that mimics the brain has been around since like the 1940s. It was only this century that it really became possible, though, because of really kind of three things. One, we had some scientific advances in deep learning. We had the availability of really big, large amounts of data. It turns out you need huge, vast amounts of data to configure these neural networks. And you need lots of compute power. And it turns out that there was a particular type of computer processor that was really good at doing all the mathematics to build these neural networks, and that was the GPU. So this whole AI revolution that we're in, I'm sure you're aware of it, has really been supercharged by the GPU and the availability of big data. So that's just a quick intro to, hey, what is AI, machine learning, deep learning? What are these things that we're talking about? All of these kind of lead to what we're dealing with today, which is a large language model. And that's large language models really coming into the picture. So around 2017, we started seeing a flurry of AI application. And what launched this was probably one of the most papers of AI in the last decade, which was attention is all you need. And you see the A and the I capitalized for AI. Pretty sneaky there, right? All of these individuals on this paper who worked at Google Brain, which was their research labs, have since went on to start their own companies. Brilliant, brilliant people. And the key part of this is in this paper was something called attention mechanisms and the transformer. And so what are large language models? LLMs are AI models built to understand and create human-like language. Once it was able to start to understand and translate human-like language, this is really where it came to kind of be what it is today. They're large because they have billions of adjustable settings. These are called parameters. What do they learn from? LLMs, for the like from a simplistic standpoint, are basically trained on the entire internet, right? There's all kinds of different things out there that it's trained on, but just to keep it simple, let's just say that it's trained on most of the internet. This helps them pick up on grammar and facts and even common sense and be able to translate different languages, right? What can they do? Incredibly versatile, translate, summarize, answer questions, write stories. I'm sure this audience is probably all familiar with things that large language models can do. But I wanted to bring that up, that paper that really started this push in 2017, because you hear this term a lot and you may not know what it is. And I think this kind of overview might help. So when you hear the word GPT, we know that it's generative, right? We are generating new something, whether it's text, audio, images, video now. We are generating something. Pre-trained is, we know that these large language models are trained on vast amounts of data. So it's pre-trained on the entire internet. And then transformer is the T. That is that transformer architecture that kind of came out of that paper. So transformer, how it processes the language, pre-trained generative capabilities. And these are the large language models that we're used to working with, things like ChatGPT, Anthropic Claude, Google Gemini, etc. Any questions so far on anything we've covered? All right.
We don't have any so far, but I hope we will, because otherwise I will ask the questions the next time.
All right, no problem. All right, so that's kind of my intro. I think one of the most important components to working with large language models, whether you are on the consumer side and you're just using a product like ChatGPT, or you're building intelligent applications, is learning how to talk to robots. And I'm not a huge fan of the term prompt engineering. It feels very kind of gatekeepy, like it's not like it's some special skill, and it's really not. It's just all about learning clear communication, which we can all develop. Just like with human beings, right? There are certain things that when we talk to another human being, we kind of inherently do. We need to kind of translate those skills when we're communicating with robots as well. Now, structure determines success. Giving context, examples, and specific instructions really help out. I like to think of this as teaching an LLM something, not commanding. Don't like, go do this for me. Like, here's what I'm trying to get out of this interaction, right? So when it comes to prompting, I think we all know this now, but just to kind of recap, bad prompts are, hey, write me a blog post about AI. Think about if you're in the office and you did that to a coworker. You just walked over to their desk and said, hey, write me a blog post about AI. Unless this is something they do every single week and there's like a certain structure to it, they're going to have a lot of questions, right? Like, okay, who's my audience? Do you want to give me, that's a pretty broad topic. Can you tell me what specifically about AI you want me to write about? How many words am I supposed to write? What is my style and my tone? What is the reader going to get out of this? So there's a lot of questions that this leaves open, and this happens to LLMs too. They will respond to that, but they will do the best they can to kind of give you an answer to that. We can get better results. And by the way, this was me going to ChatGPT in 2020, typing in something like that and getting a terrible response and going, oh, these things are dumb. They don't know what they're doing. This is not going to last, right? And it's because it is all about effective communication. So a better prompt is, hey, write me a technical blog post explaining neural networks to junior developers, focusing on practical examples. Include code samples in Python and keep it under 1,000 words. So that is a much better prompt because we are giving it more information on what we are trying to get. And again, I mentioned my newsletter earlier. I have some articles on that specific topic. So some more techniques when prompt engineering. So be specific. Write a 500-word blog post about sustainable gardening for beginners. Way better than write about gardening, right? I love this one. Use examples. I want an email that sounds professional but friendly. Here's an example. Dear team, I hope this message finds you well. So we are giving the system some examples of what we are trying to accomplish here. Context. As the marketing manager for a small local business, I need to. This is context now. The large language model understands like what point of view you're coming from when you're trying to tackle whatever problem you're trying to tackle. This is a big one too, requesting formats. So if you don't request a format, you're just going to kind of get whatever the AI wants to give to you. But if you say, please format your response as bulleted list or maybe Markdown or maybe HTML, whatever we're trying to get out of it, that's going to be important. Both on the consumer side, and it becomes very important as we start to build applications because we need that response in a specific format. Most importantly, this is an iterative process. Don't just go in with a prompt, expect like the end all, the heavens are going to part, and this is the greatest answer in the world. Depending on what you're doing, right? Like if you ask how many states are in the United States, you probably get a good answer every time. But if you're trying to get creative and get a creative answer, it may not be what you're looking for the first time. So start with a prompt. Don't try to overthink it. Iterate on that and improve and see what you can get out of it. And then I like to save what works. So keep a collection of your most effective prompts, reuse them, and adapt. This could be in a notepad somewhere. This could be in a Git repository somewhere. I use Claude projects, and I know OpenAI has this idea of projects where you can save some like system level instructions for things that you can do. So, hey, try and save the things that are working from you. Okay. We've gotten through all that. One of the things that we really haven't talked about yet is kind of money, right? Like what does it cost to use these large language models? And I like to say tokens are the currency of LLMs. Now, if you are going to something like ChatGPT and you sign up for like a $20 a month kind of thing, then that is just like, hey, I'm paying $20 a month. I can use ChatGPT all the time. ChatGPT is the product. What's going on underneath the hood is we're talking to a specific model like GPT-4o. That is the LLM. And when we're using the API, when we're building intelligent applications in Java that are talking to these models, we are paying a certain price for those. And these are all based on tokens. And I'll show you an example of this in a minute, but there are ways to go out and like put some text into a tokenizer and visualize what a token is. A token is roughly 3/4 of a word. So 100 tokens is roughly 75 words. But if you put some text in there, you can kind of visualize what a token is. So again, if you go out to like ChatGPT, you can pay $20 a month. But if you are using the API, it's very important to pay attention to pricing. Because if you look at all the way at the top, GPT 4.5 has a certain context window size, and then the pricing is $75 for every 1 million tokens that we send to the model, and $150 for every 1 million tokens that we get back from the model. If you go all the way down that list and look at something like Gemini 2.0, much, much more cost effective at 10 cents per million and 40 cents per million. So if you are going to be using this in production with high throughput, this is very important. I've used an OpenAI API account for the last like year and a half. I think I've put $10 or $15 in it for my local development, and I haven't run out of money there. So if you're just kind of using it on your machine and not pushing a whole bunch of throughput into your application, it's fine for just kind of testing locally, but definitely something to think about as we move to production. All right. So I said this at the beginning, but when we hear the term AI and software development, we have been associating that with Python, and rightfully so. So there are a lot of frameworks, a lot of projects and tools in the Python space for data science, for machine learning, for building out these large language models. But I want to separate that today. I want to say, okay, that's one side of things, right? What we are doing today with these large language models is we're not building out our own. We are consumers of these large language models. So OpenAI's GPT, Anthropic's Claude's, Google Gemini, right? These are all LLMs that we can consume. And most of them are just a REST endpoint, or they have an SDK, right? So we can do this in any language that we want. So now it's not so much AI is a Python thing, because we are, whatever language we are in, we are consumers of the large language models. So when it comes to Java and AI, we want to leverage artificial intelligence in our Java applications. And the Java and AI opportunity for me is Java powers 90% of Fortune 500 companies' backend systems. AI capabilities are now expected in enterprise applications. I'm sure there's been discussions in your organization already of like, how can we leverage AI in each of our products? Where can we kind of take advantage of this? It's no longer a nice to have. It is, we need to figure this out, right? And Java developers have a unique market advantage with AI skills. So what are some of the use cases for Java developers? Really, this is kind of one of the big things, is like trying to find out, past just like a chatbot, what are the use cases for you in your organization? So a lot of it is, hey, we want to process a whole bunch of documents. We want to extract knowledge from there. We want to make it available to our customers. Intelligent customer service automation, those are kind of chatbots. Hey, I want to generate code. I want to create developer productivity tools for our organization. We want to do some predictive analysis with all of our enterprise data. So that's where I see kind of Java fitting in. And before we get to anything else, again, if you were to go over to OpenAI and sign up for an API key, you can start using this via a REST endpoint without any programming language. You can do this right from curl. So I can make a curl request to this endpoint, pass in my API key, and then give it a message. So tell me an interesting fact about Java. And just like you would expect on the front end consumer side of things, we get a response back. Now there's a bunch of metadata in there. We'll talk about this as we go. But the content that comes back, that is the actual response. So there's an interesting fact about Java in there. So we don't even need Java to get started with kind of using generative AI. Now we can use Java. We can go in here and do a similar request. So I have my API key. I have this multi-line string that defines the kind of request that we're going to send off to, in this case, OpenAI. We use the HTTP client from JDK11, and we send off a request and we get a response. We get something very similar to what we saw before. But if that's all we needed to do, we wouldn't need projects like Spring AI. Spring AI is so much more than a facility for making REST API calls. If that's all you needed to do, you could just do that yourself, right? Where framework really comes in is as we start to build these real world applications, there is going to be a bunch of problems that we have to solve for. And Spring AI has a bunch of those solutions for us. So I'll quickly just talk about it, one slide, and then we'll go into some code. What Spring AI is. AI for Spring developers. And I don't even know if I like saying that now too, because AI for Spring developers, I want to say AI for Java developers. So the same way that like Spring got me into like building enterprise applications as a Java developer, even if you're not a Spring developer, I feel like this is a great kind of way to get into Spring, which is a framework for building generative AI applications. So you can find more about it over on spring.io. This was started by Dr. Mark Pollock, who is the team lead on this project. The current version is 1.0.0 milestone 6. It has a portable API support across AI providers for multi-modalities. And what this means is that there are all these different models out there, right? From different companies. And it seems like a new model kind of pops up every single week. And what we do is we have this portable API. So when you write code, you are writing code to an interface, the check client interface, if you will, in our code. And what we are doing underneath the hood is we are saying, hey, we are configuring an API key and a model for OpenAI. If I wanted to switch that out, I can switch out one dependency in my POM, a couple of lines of code of configuration for those like API keys, and I could bring in Google Gemini, and now I'm talking to Google Gemini. Your code stays the same. And this is really important because part of this, just the ability to have all of these different large language models is some are really good at some tasks and some are better at other tasks, right? And it's really up to you as a developer. Try to figure out like which models are going to be good for the specific task that you're working on. And in even some cases, I might have two different models in my application because this one is really good at generating images and this one is really good at generating code. So I might use two different models, and we have support for that. Sorry, one thing. Okay. Cool. So there's also synchronous and streaming API options. So, sorry. One second. Okay. So the normal call that we make is going to be a blocking call, but we also have support for synchronous calls, and we'll see an example of that. This was inspired by Python projects like LangChain and Llama Index. And yeah, so you can find out more on spring.io. So before I go into my demo, let me just jump in here, kind of the first part overview. Do we have any questions on some of that stuff that we've covered so far?
Let me put some questions here, actually.
Cool.
So we have like to do maybe one step back because we have a question. Let me show it. I have a question regarding LLM models. Which trait of the model is responsible for generating the response from the vast resource of data precisely for exact query of you?
Which trait of the model? I'm not sure I understand the question.
Me neither.
Okay.
To be honest,
I thought it was just me. So I'll jump into like a screenshot of ChatGPT in a second, and we'll talk about something real quick there. But yeah, let me just do that right now. So when you go to something like ChatGPT, again, this is a product This is not the actual model, right? Up here, we can kind of pick what model we want to talk to. This is, hey, this is the product that sits on top of the model. When you ask it a question, tell me something interesting about Java. That is the user query that you're sending off to the model, and then they are sending back a response. The model, which is GPT 4.5 in this case, is the one that's responding back with the response. So I'm not quite sure on your question, but I hope that helps.
Cool. We have 2 more questions. One now from Raj. Can you use RAG in Java, retrieval or argument generation?
Yep. So yeah, again, you could do this. This is what I was saying, is that like you don't need a framework to do any of this. You can kind of build all of this on your own. But when you get into like trying to solve some of these problems like RAG, then you need, then the framework is going to help you out a lot, right? So the short answer is yes, you can do it in Java, you can do it in Spring, but Spring AI gives you a lot of tools to do this out of the box quickly.
Awesome. The last question for now. What Java version can Spring AI work with reliably?
That's a good question. So I always just use the Spring initializer. So the latest version, I think 3.3.9. I would have to look at the compatibility. I know we'd have to be on at least 3.0 because everything is JDK 17 and above. But I think it's somebody saying 3.2, 3.3, so Java JDK 17 at least. Yeah, so you need JDK 17 to be on 3.0. 3.0 is kind of out of support already anyway, so yeah, I would be on like 3.2 with JDK 17. Cool. Oh, you're on mute. I don't hear you. You're on mute. Can you not hear us too?
Yeah, now I'm talking a lot. Yeah, what would be really funny if we would like ask ChatGPT or any other prompt. So okay, tell me what is a specific version. Just to double check one thing. Why I'm saying that, we had a lot of comments when we were talking about Gemini, because some people are asking prompts and they see that the quality of prompts are not that good sometimes. Either because we are not asking the correct questions, or because we still have a lot of work to do, or the prompts in the AIs have a lot of work to do. There was a comment that a guy that created asked it to create an app, and he spent like an hour like fixing the issues because there were a lot of issues. So it's a common thing, right?
Yeah, it is. And there are a couple things going on there. One, we know that we said earlier, these large language models are trained on vast amounts of data, right? But they do have a cutoff date. So OpenAI's GPT's cutoff date is something like October of 2023 still. So it only is trained on a certain set of data. What it can do, though, is then go out and search the web for relevant answers to kind of fill in that missing data. So yeah, a combination of understanding the limitations of the large language model and being able to like properly ask the large language model what you're trying to get out of it, instead of build me a Spring Boot app that takes over the world, right? Like it's not going to really figure that out. Cool. All right. Well, let's write some code. Oh, you're on mute again.
I do this all the time with myself. Jesus Christ. So we have more questions here, but I think it would be nice to see the demo first, and then we can jump back to the questions, because they're super specifically about Spring and in protocols, etc. Cool.
Perfect. All right, we'll go into that then. Okay, so the code that we're going to go through today, we're going to do a little live coding, and then we'll look at some of these examples. We don't have time to go through all these, but I want to leave you with this repository if you want to learn more. GitHub.com/Dan Vega Spring-AI-workshop. I just updated this last week to the latest milestone 6 and added some examples. So there's a lot of fresh code in there if you want to follow along. If I want to get started, I just need to go over to start.spring.io. This is kind of where I start all of my Spring applications, right? Using the Spring initializer. I'm going to use Java and Maven, the latest version of Spring Boot. And I'm going to go ahead and pick a group here, which is dev.danvega. And then we'll go ahead and call this the VJug. I'll leave all this the same, and then we need to add some dependencies. So I'm going to build a web app, and then all I need to do is pick the model that I want to work with. Again, there's so many different large language models out there. I can pick whatever one I want to work with. Today, I'm going to work with OpenAI, which means you need an OpenAI API key. Again, you can go over to their website and sign up for it if you want to follow along. But this is essentially all I need to get started. Now what I can do is I can go ahead and generate this, and this will download a zip file. And then I will go ahead and open this up in IntelliJ, and we can take a look at this together. So let me pull this over here. And here we go. So I have just a standard Spring application. Okay. Again, what I said was when we pick the large language model that we're going to talk to, we get the appropriate Spring Boot starter. So in fact, we are using the Spring AI, OpenAI Spring Boot starter. If you were to use something like Claude, you would have an Anthropic starter, Google Gemini, etc. So we have that. And because we only have one on there, we will get a default chat client implementation that's created for us. But to do so, we need to give it some properties. If we were to just start this up, it would fail because we haven't defined that API key. So I need to say Spring AI, OpenAI API key. Now I could come in here and just kind of copy and paste that in. It's kind of bad practice, right? We don't want to hard code our API keys right here in our code because we might end up checking that in. So I have an environment variable that will kind of abstract this out. And now those credentials will not get leaked. The only other property I need to set is the model. So there is well, you probably don't even need to. There's default models, but I want to be very clear on which model from OpenAI I am using because again, I showed you that pricing structure. This is going to cost money. We want to be very clear that we are using the appropriate model. So in this case, I'm going to say I'm using GPT-4o. Now, there are a bunch of other properties you can configure to kind of fine tune everything, but this is really all I need to get started. So what I want to do is just create a simple application that does what we did on the front end. I want to ask GPT-4o a question, and I want to get a response back. So I'm going to do that by creating a command line runner here in Spring. This is just something that will get created once the application context is ready. So we have access to all of the different beans that are available there for us. So one of those is a chat client. And I told you earlier, this is the main interface. And this is what allows us to write the same kind of code to whatever LLM we're going to talk to, right? It turns out we get one of type builder that will get created for us. So if we look at builder and we look at this, there is a default chat client builder that implements builder. And again, this will we'll get an instance of this for us. So in here, I'm going to say return args, and now I can create a client. So I can say builder.build. And this should look pretty familiar if you're in the Spring ecosystem and you've used something like the REST client. This is kind of a similar pattern. Now that I have a client, I can talk to the LLM. I can say, hey, client, I want to send a prompt off. And that prompt is, tell me, actually, let's say, what is the virtual Java user group? All right. And then we can go ahead and make a call to it. So I said in a little bit earlier, we can make a blocking call or an asynchronous call. The call method is going to make a blocking call. For this one, I'm okay with that. And then we saw a responser that had a bunch of metadata, right? Like the tokens, what the response was, like a whole bunch of things. We could get that data if we want, but we can also just say, hey, I just want that string response back. I want that content back. And so I'm saying content, that will be my response. And then I can go ahead and print this out to the console. So I'm going to go ahead and run this. If everything works okay, we should get a response down here in the console. And it will be telling us something about the VJUG. And it does. It says a virtual Java user group is an online community for Java developers worldwide. So that is, at its core, kind of the simplest way to get a client, create a client, and then talk to an LLM. And again, in this instance, we're talking to OpenAI's GPT-4o because that's what we've configured. If we wanted to swap out some properties, this code does not change. And I think that's a really big deal. So, okay, let's look at one more, and then I'll kind of show you some examples from that workshop. Let's go ahead and say that, let's do this. All right. So what if I asked something? I'm heading out to San Francisco next week. So what if I said, we can pass in a user message here. What if I said, I am visiting San Francisco next week. Give me 10 places I must visit, right? Again, we're going to make a blocking call. And again, we're going to get the content back. I'll create a variable from that. And then I'll go ahead and output this. So let's say response. All right. So I'm going to do this, and we are going to wait for a minute, right? We are going to sit here and wait and wait and wait because the large language model is translating that or retrieving that response for you and sending that entire response back. This is great in the situation where it's a short answer, like what is the VJUG? But when we have all this text, like when we're on something like ChatGPT, we get all of this text streamed back to us. And so being able to stream this back to us is pretty important. So we have streaming support. So if you wanted to come in here and instead of calling just call, you could call .stream. And then in this case, that is no longer a string. It is a flux of strings. So you could go ahead and just kind of stream that out if you wanted to. So support for both synchronous and asynchronous. Now, again, because we don't have all day, I'm going to bring in this other project here so we can go through a few more examples. And the next one I want to talk about is this prompt. So let's pull this up. And we'll come back to this in a second. No, all right. So I have this article controller, and I have this chat client. So I create a new chat client. I have an endpoint that will basically allow me to create a new blog post. We saw this example earlier, but what I can do is there are different levels of messages. So remember, when I go to ChatGPT and type in that question or my query and send this off to whatever model we're talking to, that is a user message. So this is the user-defined query that we're sending to the LLM. There's also different message types going on behind the scenes. There is a system level message, which allows you to kind of define the overall context of this conversation. There is an assistant message, which is the response they send back. And then there is a functions or a tools message, usually a tools message, functions message that allows us to define some external tools that these LLMs have access to. So here I'm setting a system level message so that I can write a blog post about something. Again, we know this is a bad kind of prompt, but we can set a system level message to say, hey, if you're going to write a blog post, here's the length and purpose. Here's the structure. Here is the content requirements. Here's the tone and style. So that all we have to do is pass the topic to this message, and then we get a blog post out of it based on topic. But every single time, we don't need to write this massive prompt guiding the system to get me to the point where I want the type of response that I want to get back. So that's one example there. And then from the user standpoint, we saw the ability to pass in just a text string, like write me a blog post about this. But what if I have like some parameters I want to replace in there? This user can also take something called a prompt user spec, which allows us to set the text and also go ahead and replace some parameters and also attach some media to it. So that is just passing that in, and now we can set the text and replace that parameter with whatever comes in to this particular, in this case, we're just passing it as dogs, right? So that's a little bit more about prompting and different messages. The next thing I want to talk about is output. So let me see here. Do we have AI Studio open? Yes. So I just did a video on this today, actually, but this would be a good thing to talk about really quick. If you go off to an LM and you ask it something, you are basically playing roulette. You have no idea what it's going to send back, right? And for the same type of question, you may get 10 different responses from this LLM. You might get another different response from another LM. So here's an example. Can you name all of the NBA teams, right? So I don't know how this is going to come back. It could just be a list in alphabetical order. It could kind of separate them by conference. It could separate them by conference and division. I have no idea how this is going to come back, but we're going to go ahead and send that off and hopefully get an answer. Oops. Let's go here. Ooh, that is failed. What's going on, Gemini? All right. So we didn't know how this was going to come back, right? It came back in alphabetical order by team name. Okay, that might work. And again, on the consumer side of things, if I'm just asking a question and getting a response, maybe this isn't a big deal. But in an application where I need to get a response back and then turn that into a type that I can work with in Java, this is not going to work for me. I need to know that I'm getting it back in a specific way. This is what's known as structured output to different LLMs. And again, another thing that LLMs kind of, or Spring AI kind of solves for us. So on this, and here's the kind of the other kicker of this, is that each LLM has a different way of kind of using structured output. So I'm using Google Gemini right now. I'm in their AI Studio. And this allows me to like tweak some knobs and like test some things out. One thing I can do here is test structured output. I could come in here and actually type out the JSON, or I can use this visual editor and I could say, what I want back is something called teams. This is going to be an array. And inside of teams, I want a team name, maybe a city, maybe a conference, and maybe a division, right? I want all this information about NBA teams. So now what I can do is I can save that and I can ask the same question and let's see what we get. It's not adhering to my output, but this is better. So I'm basically saying, hey, teams, get a collection back. Give me the city and the name. For whatever reason, it didn't return the other two. But this is structured output. Instead of just trying to hope for the best that they send you the right information, we're going to send some information along with the request to say, hey, this is how we want this back. And again, every kind of LLM implements this different, and Spring AI will kind of take this and do this under the hood for you. And so I just want to see a simple example of this in code. If you go to output and vacation plan, so I have one here. So if I were to call this endpoint, what is a good vacation plan while I'm in Montreal, Canada for 4 days? I was there a couple weeks ago for Confu, and I wanted to know where I should go. If you don't give it any structure, any desired output, it's just going to give you whatever it thinks, like whatever the answer could be, right? But in a structured output, instead of calling .content, I'm just passing it an entity. So I have defined a type here called itinerary. Itinerary is a list of activities. Activities are made up of activity, location, day, and time. So now I've defined the types that I'm interested in. I pass that into entity. What happens is underneath the hood, we take that, We create that JSON schema. We send that along in the user request. And now the LLM knows, hey, when I return this back to you, this is the structure that I wanted in, this itinerary. So we're going to call localhost 8080 / vacation / structured and see what that does. All right, so now we get this list back, we get this itinerary, and it has an activity, day, location, and time. So this is the information I cared about. We knew how to get that, so we told the LLM how we want it structured. And now because of that, we know what's coming back. We can deserialize this into a type. Now we're in an application, we can work with types, right? So this becomes very important when you start to work with in real world applications. So we're running out of time, but I want to do just a couple more things. We've talked about text. We've worked with a lot of text so far, but we also have the ability to work with multimodalities. So in this case, I have an image to text endpoint. And what I'm feeding into this is this image. And it looks like a little laptop on a Nook. There's coffee, there's glasses. It looks like a MacBook. And what I'm going to do is I'm going to pass this to the LM. Again, through this user prompt user spec, I'm just saying, hey, can you go ahead and explain whatever image you see or what you see in the following image? And I'm passing this image. I'm just using a class path resource here to kind of point to that image. So we're going to go image to text and see what that says. And this is remarkably good at being able to take an image, process it, and then answer questions about it. The image shows a cozy setup on a bed. There's a laptop with a logo placed on the bed, and in front of it, a wooden tray holding a mug with coffee with latte art on top. There's glasses, etc. I'm not going to read the whole thing. So really good at being able to work with different modalities. It's not just chat. You can use chat, you can use audio, you can use chat, audio, images, etc. All right. Another example. Let's see. Just checking time. All right. So the other thing I want to kind of talk about is we've saw this on like the front end of ChatGPT, right? So if I say, hi, my name is Dan. Okay, it's Dan. What is my name, right? It's going to know your name is Dan. And again, this is because ChatGPT is the product that is sitting on top of and talking to the models. We know the web is stateless. We know that the model itself has no recollection of who I am. This is the product remembering state. So if we were to kind of build this into our own application, if we were to do this without this line here and go ahead and ask it a question like, hey, my name is Dan. Now, what is my name? It would say, I have no idea. I don't know what your name is. But we can build in this chat memory into our applications in Spring AI. And we have these things called advisors. So if you want to take a look at the Spring AI reference documentation, really good, that kind of covers what advisors are. But we have different advisors. One is like a message chat memory advisor. One is for doing RAG, searching over like your documents. So there are some different advisors that we have that we can go ahead and use. So in this scenario, I'm saying I want to use this message chat memory advisor. So now when I go ahead and ask that to my application, so again, this is at the /memory endpoint. So let's say 8080 /memory. We'll say, hi, my name is Dan. And then we'll just say, what is my name? And it says your name is Dan, because now we are holding that memory. So if you need to do something similar in your applications, you can. There are some kind of knobs that you can turn to configure that. You can define how much you want to hold in the context, because Something we haven't gotten into, we haven't been able to talk a lot about today is like all these different large language models have a context window. So you don't want this to balloon up too big because you are going to be paying for that. Again, tokens are kind of the currency of LLMs, right? And then there's also ways to associate some type of chat ID to it. So if I log into your application and you log into your application, we have chat IDs, we have like some type of unique ID. We're just holding message context for me and just holding your message context for you. Okay, one more example, and then we'll see if we can't get to some questions. So again, one of the problems with these large language models are some of the limitations. I won't say problems. Limitations are it's been trained on a vast amount of data up into a certain date. Once it's been trained on that data, if you were to ask it a question, it's not going to really know, right? So here's an example. Now, I can't do this on ChatGPT because it has the ability to search the web. But if I was going to say, how many Daredevil Born Again episodes are out? All right. If I were to ask it that, it's going to say, I don't know, because Claude doesn't actually have the ability to search the web. So it's going to say, hey, I'm not really sure about that. If we go over to something like ChatGPT, it's going to figure out quickly searching the web because I don't have that information. I need to go search the web for the information. So when we talk about limitations of LLMs, and we need to kind of extend the capabilities of an LLMs, there are different ways that we can do this. One of which is, in this case you just saw, is providing a tool that provides search functionality. Another way may be just adding some context to, or adding some information to the context as we send it off to the LM. We heard about RAG earlier. RAG's another way, and there's some examples in this repo of that, of, hey, I have all my documents. I don't want to send them all along every single time. I just want to like find needles in a haystack in that document and send that along as context. How can we do that? And then there's the idea of tools. So in this case, I have a tool, and this tool is called Date Time Tools. And the description becomes very important. It says, hey, this tool will get the current date and time for the user's time zone. Because if I ask the model right now, what is tomorrow's date? It's going to say, I have no idea. I don't have real access to real-time data or events. But if I pass this tool along, and I pass this along as the context, the LLM will say, I don't know, but I do see that you have a tool that can answer that question. So I'm going to send this back to you. You execute that function code, send that information along back to me, and then I'll be able to answer that question. So this kind of handshake works pretty fast underneath the hood. I know that sounds like there's a lot going on there, but it works pretty fast. And this just says, hey, I can go ahead and return a date. And so I have this date time chat controller. And all we need to do is make sure that we are attaching the tools that are needed. So if we had like a real-time web search tool, if we had a weather tool, if we had some type of local file system tool, we are passing those tools along to the LM, so it knows that if I come across a question like that, I know that I can kind of send that back to you. So again, we didn't get to go through a ton today. There's a lot of examples in here. If this kind of piqued your curiosity, I think this is a good place to start. The Spring AI reference documentation is really good. I would kind of dive into here and look at, just kind of search through here because there's a lot of great information. We talked about, the different AI models. Like if you want to find out which models are supported, there's a huge list of them. You could even work with open source models on your own machine using something like Ollama, which is really nice. A lot of pros to doing something like that. So a whole bunch of features that we just couldn't cover today, but I hope this was kind of a good introduction to building generative AI applications in Java with Spring AI. And with that, I'll take some questions.
That was awesome. So we do
Thank
have
you.
some questions.
All right.
Let me put some in the screen. First from Cabby, can we use something like LangGraph, where AI will choose agents depending on the context?
I have not played with building anything like agentic yet. If I don't know the answer to that, but if you go out to the Spring IO blog, Christian, who is one of the main developers on the project, has a couple of blog posts where he talks about building agentic workflows in Spring AI. You can kind of read through it there. That again is there's so many things on my list of things to learn. That's coming quickly on my list to learn next. So.
Awesome. The next question from Digital Groot. Build applications, architecture / deployment structure of Spring AI apps will be different from standard Java apps?
No, you can think of this as just another project that you're kind of using in your Spring application. So I liken it to something like Spring Data, right? You can talk to a database with strictly Java with the JDK, but those are low-level APIs, right? Like Spring comes in and Spring Data, more specifically, adds some abstractions on top of that so that if you want to easily talk to a database, there's a nice API for that. Then there's like another abstraction that allows you to talk to SQL databases or NoSQL databases, like whatever the case may be. It's just another project in the Spring ecosystem. And as you saw, we created it from start.spring.io. We brought in the dependencies we needed, and we were off and running. So
we could see in examples as well that like super Spring oriented, right? So it's basically if you are like familiar with Spring, we can just of course we need to learn a little bit of Spring AI, but it's super straightforward.
I think so.
Cool.
Yep.
So next question from Jovan. Can you please explain a little bit what are tokens?
Yes. Can I share my screen again?
Of
I have
course,
an app here. Just real quick. Let's go back over here. So again, as we start to like interact with these models, and I ask a question, how many teams are in the NHL, right? So as I do this particular message that I'm sending to the LM is the user message. And this message that is coming back is the assistant message. All of these things are contributing to what is called the context window. And so again, a token is roughly 3/4 of a word. But if you don't want to like figure that out, I can copy this over, come over to something like Tick Tokenizer and a user message. This is my user message. We don't have a system message. This is essentially what's getting passed back and forth. And if you look in here, these are the unique IDs for that token. So token 1 is how, token 2 is a space plus many. There are 14 tokens in this particular request. But again, they sent something back. So this is a response message. That conversation of me sending a message and them sending a message back accounted for 54 tokens. This is important because this is how we pay for LLMs, especially when we're using it from the API standpoint. So remember I said pricing is per million. So million tokens that I send to Google Gemini is going to cost me 10 cents. A million tokens that I get back from Gemini is going to cost me 40 cents. And again, all these different LLMs have different pricing structures. So it's definitely something you want to pay attention to. Not so much on your local machine, just kind of tinkering around, right? But as we want to put these things into production, that matters.
Awesome. Next question from Zakaria. What is the difference between MCP protocol and Spring AI?
Cool. So Spring AI is really a framework for building enterprise applications that need to integrate AI. MCP is a protocol that came out from Anthropic, And it really kind of like USB-C standardized the way that we get external data. So I showed you that example before. I asked Claude about Daredevil Born Again. It says, I have no idea about that. When we run up against those limitations, there are things that we'll want to connect to. I want to search the web, or I want to talk to this database, or I want to talk to some API, or I want to talk to my local file system, right? I want to talk to GitHub. I want to talk, whatever the service that we need to talk to. We have to make these available to the LLMs, right? So MCP is a protocol that says, here's a client, here's a server. Here's how you define those things. So instead of me having to define how I talk to GitHub every single time from an LLM, this defines a standard and said, here's an MCP server for GitHub. I don't have to reinvent the wheel every single time that I do that. But you need a client for that. And the clients are like, there's Claude Desktop, so it has a desktop app. There are things like Cursor and Windsurf that you can plug these MCP servers into to kind of extend its functionality. So two different things, but we have support for MCP in Spring AI for building MCP servers. And in fact, the SDK, the official SDK for Anthropic, was given to them by the Spring team. So the Spring team put together the official MCP SDK, and that was contributed over to Anthropic. So if you look at the documentation for that, you'll see all of that in there. So definitely interesting.
It's pretty nice.
Yeah.
Next question from Dimitri. What about ML ops practices? How Spring AI supports them?
Yeah, so this is where we're going to get into what I talked about before. We are living in two worlds here. There is the machine learning, deep learning, data science world that I am not in at all. So those words that you just said to me, I don't really know those. I am more on the consumer side, like these large language models are out there for us to consume. I am a consumer of them. I can go ahead and use them. So I don't think that that side of the equation is really supported.
Cool. Next question from Altin. In what time frame do you think Spring AI will implement OpenAI's Agents SDK?
Yeah, so this just came out yesterday. I saw that. I was very excited to see that as well. But that Agents SDK is written in Python. So I don't know the answer to that. What I do know is that, again, if you go back to the Spring AI blog, Christian has written some really interesting blog posts on building agentic workflows in Spring AI, because AI agents is the conversation of 2025, right? These are the things that we want to build. So there are advancements being made towards that. To take a look at that, I would start there if you're interested in building agents. But yeah, I don't know the answer to that. Sorry.
No problem at all. So next question from Vikran. Awesome talks. It's really nice talk actually. Is the state stored in memory of model limited to the numbers of token as per context window, or it's there's separation like between the cost and the memory state?
Yeah, so we are sending, this is basically building that context window up and sending it every time. So that is something you need to be aware of. Again, we didn't talk about it a lot, but different models have different context windows. So something like GPT, I think, has 128,000 context window, where some of the Google Gemini models have 1 million context window. So you can send a lot more information, but you want to be careful about that, right? Like, do I need to send all of this information every single time? If you do, use one of the models that have a larger context window, but yes, be aware that every single time we do this, we're building up that context window. We're sending that along to the model. That's why if you're on the front end side, I always say, if you start, if you start building up a long message, hit that new chat button, because now you've kind of cleared that context window and you're starting a new fresh chat window where they don't have to send this context all of the time.
Cool. Martin has a question that if I use memory for chat API, does the previous question's answer count as a token in pricing as well, or it doesn't count?
Yep.
It counts.
Yep. Oh. Everything is building up. So if we start with 0, and then we had a 54 token count, that first message. And then I asked another one that's at 54. We're now at 108 every time that we send it. So if we just said nothing, now we're, we're just building that context window every time. So you want to clear that out the same way you would on the front end. On the back end, you want to clear that out if you start like a new session or a new kind of chat, right?
Yeah, that's the we don't expect that will cost that much, right? But it was a super nice explanation about the tokens because we need to be aware of that.
Yes, and something I didn't mention that we couldn't go into today is in Spring we have observability, and Spring AI is plugged into all the observability. So if you include something like the Spring Boot actuator, you can start collecting metrics on all of this stuff. We're already doing that. So if you plug in something like Prometheus and Grafana, you can build some dashboards to start to see like how many tokens are we taking like per request, what's the max tokens, what's the min tokens, and you could adjust some settings. So one of the settings we didn't look at was, hey, don't allow any more than this number of max tokens in a request. So maybe you could send 1 million to Google, but I don't want to send 1 million every single time because that's going to start to cost me, right? So yeah, those things become important.
They're super important. And the Java guy wants to know if you have tried using the @2 methods to expose entities from the DB to LLMs, so that LLMs can answer some questions about the data in your app.
Yeah, so the tool really exposes whatever you want to expose. So I said, hey, the classic example is, what's the weather like today? I don't know. I don't have access to that. But I could provide a tool that will call some API, some weather API, get that information, and then send that along. Similarly, what if I was in an organization that had some kind of microservice over here that was related to customers? And I wanted to ask an LLM, like, how many customers are on our SaaS platform, ABC? It's going to say, I have no idea. But if I provide a tool and it comes back to me, now all I'm doing really is calling some other service that could talk to a database, retrieve that information, give it back, and send it to the LLM. Now, again, we get into like some privacy and data concerns, like, do we want to send this to a public LLM? You can use on-prem, open source LLMs to run on-prem. But yes, you can use tool to basically augment the LLMs with any information that you need to.
Awesome. Unfortunately, that's all the time we have for today. One reminder for all of you. In VirtualJug, we do have a Slack, and we do have a Slack channel specifically for Spring with more than 600 developers there. So if you guys are missing or will remember later to ask a question to them, please send it there. That will be like, then we'll be there to answer your questions. Anyone will be there answering your questions. And a huge thanks to you, Dan. I learned a lot. I think the audience learned a lot as well. And we hope that won't be the last time you see here in the VirtualJug.
No, not at all. Yeah, and sad I'm not going to be at DevOps UK this year. I've never been there. I'm trying to get there one of these years. Maybe next year will be it, but best of luck to everybody who's going there and speaking at those wonderful conferences that I get to watch online all the time.
We hope you're at that one soon. But yeah, thank you so much to both of you. That was an amazing session. I didn't actually know how tokens worked, and I tend to do different calls, but I realized maybe I need to watch how much context I'm putting in that window. So that was really helpful for me as well.
It is important,
especially kind of remembering all those things. But a huge thank you. And yes, Dan, hopefully this will not be your last visit to the VirtualJug. If everyone listening enjoyed today's session, would like to see other sessions from us, have particular things they'd like us to cover, please let us know. We built this community for you. And so we're very lucky that we have amazing people like Dan offering to speak at our events. But again, if you'd like to see something specific, just let us know. If we're not covering it, we can also go find out which jugs are covering it locally and hopefully live stream it. As I said, we live stream other jugs as well. Let me see if I can actually show you what's going on here. We've got a VJug Connect event, as I said, for the London Java. Let me see if I can do this properly. The London Java user group coming up, and that's on the 25th of January. It'll be at 6:10 p.m. UK time, so very similar time to this live stream. and we're going to have 2 sessions, one on reactive programming and one on Java and the infra from Code Vision. So those 2 sessions will be live streamed on the 25th. But other than, let me see if I can stop streaming now. Too many tabs open. But other than that, we also have another session coming up for the VJAG. It's not live on our meetup page just yet. Really sorry about that, but it will be in the next few days. And we will be joined on the 23rd of April by Tom Cools and Ixchel Reyes. And they'll actually be covering also another AI session. They'll be covering LLMs can't optimize schedules, but AI can. So I'm sure that'll be a very, very cool session. So please join us for that. And as I mentioned, I launched an event today called AI Native DevCon. And it's all about AI for software developers. We're going to be talking about current AI tooling and what's happening at the moment. We're going to be talking about the future of AI and what we can expect from our roles and the tools and how we program as developers in the future. As well as we've just implemented a very cool tools in action session where people are going to not only do tool demos, because we can find those all over the internet, but actually show us what they're building, how they're building it, what they're using. So if you want to head over to either that link, because then I know that you've come from here and it's nice for me, or you can just go to ainativedev.io/events. Dan, I can actually, I can see you're on the right screen. So I'm actually going to show your screen. No, you've gone off.
Yep, I'm here.
There we go. I'm going to add Dan's screen back to the stream and you'll actually be able to, it's not working anymore, be able to see this is our latest event. So join us. Our CFP is currently open. So if you've got a talk you'd like to share, if you're playing with some cool tools and you're like, I've never done a talk, Sam, I'm scared. Don't worry, we can do sessions beforehand. I'll guide and mentor you through the whole process, but we want to hear what you're building. So please join us for that. But that's all the time we have for today. So a huge thank you again to Dan and Elias for this amazing session. Join us again on the VJAG live stream. If it's not for the Java community, London Java community event, hopefully it'll be for a Java community event in your area. Otherwise, I want in April. And other than that, thank you so, so much, everyone. And we will hopefully see you all soon. Goodbye.
Thanks for having me.
Bye-bye.